could do that. I don't reject that. That's a decent idea. Of course, my fraction's still big and ugly. What should we do? Oh. Yeah. So what does this mean? To divide by the reciprocal is the same as doing what? Right, so this is equivalent to multiplying that by m plus 2 times the numerator. Right? So we can do that. And then it simplifies, I mean, we can make progress here, right? So then we get, you know, m times m plus 2 minus what? 1 over m minus 2. And I'm not really content with that as an answer. I'd like to combine these terms. What would you do? I mean, well, from one school of thinking, this is a good answer. All right, so like, in some sense, that's a good answer already. But if I wanted to make it into a common fraction, what would I do? I do m times m plus 2 times m minus 2 minus 1 divided by m minus 2. Which we could multiply out if you wanted, right? But anyway, like more to the point here, guys. This would have been, I would have taken this as an answer. Like I would have been happy with this as an answer here. And but for the purposes of what we're doing next time, making a common fraction would be useful for solving inequalities that are involving this expression. All right. Let's see here. So any questions about anything here before I do another example? Yep.
How'd you get from the n plus 2 times n minus 1 over n plus 2 times n minus 2 to the one that you did?
Oh, it's because what's that?
I wasn't following the position.
Oh, I mean, I've got stuff, right? Divided by 1 over m plus 2, right?
Yeah.
So this is equal to m plus 2 times stuff. I mean, it's just that.
Oh, I meant like from there to the m times m plus 2 minus m over, or 1 over.
Oh, this step?
Yeah, that's it.
So I multiplied m plus 2 times m. I just flipped the m and the m plus 2.
Okay.
And then here, when I multiply this times that, the m plus 2's cancel, and you're just left with 1 over m minus 2.
Oh, I see.
So sorry, I didn't write that down. Yeah. All right, so let's see here. Let me give you guys another one to work on. So what we're going to do here so I want you guys to see if you can do these problems, all right? So example, where are we, 13? Example 13. See if you can figure this one out. 4 over x plus 1 plus 1 over x squared minus x plus 1 minus 12 over x cubed plus 1. All right, that's example 13. This is number 67 in the textbook, all right? So try that one. If you get stuck on that one, try example 14, which is going to be 3x over x squared plus x minus 12 minus x over x squared minus 16. So you guys try to simplify these while I'm gone. I'm going to go grab your test and my computer, and I'll be back in just a minute or two. So please don't leave. Bring your test back here, and I will also prove that I'm Batman if I have time. I think I have time. My office is close to here. And I'll leave my mic here just to make sure there's no shenanigans. The camera's still on, so. Hey, let's turn my camera off. All right. I will be back. So did you guys get these problems? Did you try? You looked at it? You know, watching me do math will not make you, it's not like osmosis, right? Like it's not gonna, you have to work it out for yourself. Like the more of that you do, the better test 2 will go for you, right? Just saying. All right, well, while waiting for that to warm up, let me show you the solution of these two. I know what's going on here. So the thing is, this is x, if I remember right, this is x plus 1 times x squared plus x squared minus x plus 1, I believe. Right? So if you look at this, this is 4 times x squared minus x plus 1 divided by x plus 1 times x squared minus x plus 1. And then that I can rewrite as x plus 1 over x plus 1 times x squared minus x plus 1. And the last one, it's already 12 over x cubed plus 1. So now, after I make these adjustments, I have a common denominator of everywhere. All three of these are x cubed plus 1. And so the answer then is 4 times x squared minus x plus 1 plus x plus 1 minus 12, all divided by x cubed plus 1. And of course, you could simplify the numerator down from there. The main thing was to add fractions. It's pretty subtle here, isn't it? Now this one, the example 14, our final example, I'll just have to leave it to you guys because we're out of time. So, but because something more important has to be done in this last minute. We have to find out why I'm Batman.
I'm so excited.
So it's very exciting, I know, right? So on my website, If you go down eventually, there is a link, there are links to things. And let's see here, where is it? Mathematical distractions. Where did I put that? Oh, there it is, my random links. Wu-Tang name generator. Here we go. No internet.
I am depressed.
All right, this is the Wu-Tang name. For example, you guys may know of Donald Glover. Is Childish Gambino. There we go. So check this out. My Wu-Tang name is Thunderous Night.
Yo!
I'm Batman. So I am Batman up to a Wu-Tang name equivalence. So it's the first thing I checked. So. All right. Anyway, you can hit the off, and let me give you your test if you want them. Ah!